Okay, you remember in our last session we mentioned that we are discussing this week, week number 5, the applications of solar photovoltaic systems. We started with the grid connected and then standalone, and we stopped with the tracking, solar tracking system. As I mentioned before, when the collector follow the sun, there is sensor definitely and motor to follow the sun in this way. It will be always direct, the relationship is direct vertical, okay, line with respect to the sun. So it capture, let me say, around double what it capture in stationary system, or let me say horizontal system. Our students designed this in the lab. Sahara University designed it in the lab. As you can see here, this is solar tracking system. This is motor. They use here motor, car motors. Okay. And also this one, I mentioned it when I discussed the using of solar water pumping system. You can see here there is a small motor, which is motor, the same motor used for moving the dishes, okay, for satellites. Now, there is general question we receive always from people asking about if I want to install solar PV system for my house. How much I need, how much energy I need, how many numbers of collectors, and so. Actually, this question is general question, but you cannot answer it directly without knowing some information. The steps to install PV system, I will mention for them here as follow. First of all, we need to know the demand. It means the load for the customer, for the consumer. I mean, if you have house, how many air condition you are using, what their rating, what is the behavior of using them, refrigerator, washing machine, microwave, lights, TV, how many. So all these equipment you need to put them in a table to know. You need to know the voltage, the current, the power, the energy used, the time per day, days per weeks, and so on. All these need to be calculated. So when we calculate them, we will know what is our energy needs. After that, we need to make sure that there is space and the space can handle the weight of the PV system in my house. Then the material to be selected, we need to make sure that it can handle the weather conditions, especially here in the region. You know, it's warm, humid, dusty most of the time. So we need to make sure that it can handle this weather. Also, it's advisable to isolate them. There is some insulator we can use to isolate these systems. We want to also to make sure when we install the system that there is no shadow coming from the nearby, let me say, buildings or houses, or if I have trees, they will not make shadow to my system. Also, I need to follow the codes in the country. Losses need to be minimized as much as we can, because as example, selecting the let me say the wrong size for the cables will increase the losses. Connecting inverter far from the PV system will increase the losses, and so on. These let me say technical stuff, when it has to be considered when we design our system. What else? If we need batteries for to supply at night, we will use them, but usually batteries will increase the cost. It's advisable to have grid connected, or we use PV system for day, but rather than we use it 24 hours or you at night time. And also we need to organize and arrange with the electricity company to follow their instructions. And so, as example, today we have in the Batna, you know, we have Majan electricity company. That there is procedure. They have documents. You can, if you would like to install PV system on the roof of your house, you need to contact them. You need to follow the procedure. They will give you documents. You will sign contract. They will advise you for factory. Let me say companies dealing with PV system. They will do inspection before and after you install this. All these need to be arranged with the electricity company. Now, I mentioned for the grid connected system, Grid connected system is very simple system. We have the PV panels modules, and we have the inverter. This is, I took this photo it's in my friend house in Malaysia, in Kuala Lumpur. Okay, you see here people there are putting the panels on the roof of their houses, and they sell electricity and they got money for this income. And also this is in the lab, in our lab in National University of Malaysia, one of my PhD students work on this system. It's a grid connected system, and this is another system. Sometimes they connect batteries in the system in the situation of a critical loads. When they have a critical loads, they connect batteries. Now we discussed the connection of parallel and series. As you can see here, you already studied this in secondary school, and in level 1 you connect them in series, so the current flowing in both of them is the same current, while here in parallel we have the same voltage on both to increase voltage or current. Sometimes it's smart to use the panels here. You see here, these are panels. This is in Masdar Institute in Abu Dhabi. We visited them one year, maybe more than 15 years back. Our students, I took them and there, and we visit them. This is, you see, it makes shadow. It's not only generate electricity. It's not only give, let me say, a good shape for the building, but also it makes a shadow on the building. This is the building. And the shadow would reduce building temperature. And this reduce how much cooling we need inside the building. So it's reflected positively on energy consumption. Some losses coming from what we call it BOS, okay, which is balance of system equipment. We have some losses coming from wires, from circuit breakers, isolating switch, and so on. So all these need to be considered. It reduces the efficiency. Here are some photos I took in our labs. Okay, this is for standalone system, grid connected system, tracking system, and some accessories here. It could be circuit breakers, switches, or circuit breakers, or monitoring system, meters, and so on. We lose here part of our energy. It's advisable to connect our inverter and other, let me say, accessories, meters, and so wires close to the panel, behind the panel. Some people, what they do, they connect the inverter inside the building, let me say 100 meters as example, far from the panels, which increase the losses. We need to make sure that we connect them behind the panel. These are some photos I took in London, one of the factory companies there, which is Solar Sentry, called Solar Sentry company. Okay, inverters, as I mentioned, inverter and the panel are the main elements in a grid connected system, but meters and other components represent the accessories. This is old meter today. Most of them are digital. Circuit breakers, as example, isolating the switch. All these are accessories, but we expect that the losses increase here, but it is a must. Okay. In critical loads, we need to use batteries. Some grid connected, but at the same time there is a critical load. Okay, it's connected to provide electricity to the grid, and sometimes to provide it to the load connected at the same time. Okay, so this is in Majang company, and you can see here they use batteries. Okay, now after all this discussion, and we manufacture the cell and the panel, the module, sorry, and then the panel, we understand the model, one diode model. We discussed this before. We got equation for voltage, equation for current. That's great. Now we manufacture it inside the factory. We need to test it at the end to make sure that, I mean, let me say, to approve it, or to, let me say, to make sure that it's working according to what we manufacture for. So what they do, people there in the lab, they tested in what we call it standard test condition, STC. It is international, let me say, simple, which refer to a standard condition inside lab. We test our PV panel to make sure that module, to make sure it's working according to the ratings. This standard test condition contain three things. first thing is the insulation. Insulation, the board density is 1000 watt per square meter. We provided, and the temperature inside this lab, or let me say this room for testing, is 25 Celsius. And the third point is the mass, air mass supposed to be 1.5. Okay. When we have these conditions inside the small room, we put the panel directly horizontally. Okay, and we check the output. Okay, I will talk about this output. Have a look. Let's assume we manufactured 100 watt module panel with 100 watt. Now, usually manufacturers, what they mentioned in the specifications, that there is around plus minus 5% tolerance. What they mean? They mean that we may have error in manufacturing losses and so, which lead to have our power in this range, 100 minus 5, 100 plus 5. It means 95 to 105. Okay, so this is their meaning by when they say tolerance. Okay, just 1 second. Okay. So what happened is we go for the worst situation. Worst situation is we have 95. So if I have 100, just a minute. If I have 100 watt, I expect that I will come up with 95 out of 100. Okay. Now, since we are going to put it outside, okay, and the environmental condition will affect the productivity, then I need to consider them. I will take some of the important elements affecting the productivity. The first element is temperature. You know, when temperature increase, current increase, okay, but insignificantly. But the voltage increase significantly. Oh, sorry, reduce significantly when the temperature increase. And this reflected on power, energy, efficiency, all of them going down. So we don't want our panel to get heated. We want to cool it to increase the productivity. Now you might say, okay, how much we expect, generally speaking, how much we expect reduction? The reduction could be around 11%. So if I say 11% mean 89% of the power, then I will say, okay, the 100 here reduced to 95, and the 95 reduced by 0.89%. Okay, so I got around 85 from the 100. Here, we did, me and my group, we did good research here, and we're still working on this, on the effect of temperature and solar radiation, other environmental parameters, as example, dust. You can see here, this is a graph from one of our published article. You can see here the temperature here, this one. The temperature is high for the PV. When we cool the PV using different methods, we will talk about them in PVT topic. Okay, we will see that it get reduced, the temperature reduced. Okay, with more cooling, with using different way or methods of cooling, do different let me say fluid to cool it, then we have more cooling, and this will reflect positively on the productivity. These are some of the articles we published related to the cooling of PV. Some of them, some of this research have been conducted here in Oman, some of them outside Oman. Okay, and I try to pick here system in our lab. You see here, this is panel, PV module, and this is PVT, PV thermal. I will talk about it in a topic later on, inshallah. But what happened is it's similar to, identical to this panel, but what we do, we cool it. How we cool it? We make a pipes behind on the back of the panel, and we circulate water or any fluid inside these pipes to collect the heat to cool it. Okay, we use definitely storage tank, or let me say heat exchanger. We use pumps and so. Usually before Corona, I gave this as an assignment or a project to my students, and they work in the lab, they design it, they do the calculation, and they make measurement to do the performance, something similar to this curve. As you can see here, this is solar radiation, the black one, and voltage is this red and the blue. The red here is the PVT. You see, voltage get up. Here, this is the blue, is the voltage of the PV. Here is the cooled one, PVT. So you can see the voltage get improved. We get better voltage. So this is significant improvement. Well, if we look to the current here, this is the current, as you can see here, the current. The blue and red, they are close to each other, so it's insignificant, let me say, effect. But when I multiply both of them, I got improvement in power and then efficiency. Okay. Now, another parameters affect the performance and behavior and the productivity and efficiency of my PV is the dirt and dust. Dirt, it could be because of pollution, because of mood, because of, let me say, storms, because of birds, okay, drops, and so. And dust, you know, we know that this region is a dusty region, okay? And the problem of dust, when it's accumulated on the panel itself, when, as example, this is my panel, dust accumulated, it make a barrier for the solar to reach my cell, okay? So reduce the solar radiation. When we reduce the solar radiation, we reduce the productivity, right? So it's not good for the panel to have dust accumulated on it. Now, the dust is one of the real problems and one of the hot problems. People are investigating, working in this field, in the field of solar energy, more than 50, 60 years back. Okay, I'm talking about in 1960 and beyond, behind. After that time, people start working on dust, investigating the impact of dust on PV and solar collector in general. And it's different from location to location, from dust type to dust type, from technology to technology. There is a lot of to say here. I don't have time to talk about it, but frankly speaking, the last 20 years, one of the most hot topics I studied and investigated is the dust. I will try to provide some article related to this. Now, what happened is we expect that the dust will reduce around 7% in general. This is general rough number. Otherwise, could be increased or decreased depending on many parameters. So we are talking about 0.973% coming from the panel. So I mentioned that I reached 85. So I multiplied by 0.93, I got 79. Don't forget, we started from 100, effect of temperature, effect tolerance error, let me say, in the manufacturer accounted, which is 5%. Effect of temperature accounted. What else beside effect of temperature? Just a minute, let me see what we discussed. Temperature, yeah, temperature. And now dust. Let's see, this is some articles, I will provide them for you to expand your information and knowledge. Let me show you here just one point related to the dust. You can see here, we checked and tested the effect of dust in Sohar. We put systems in Sohar, in Saham, in Liwa, in Barka, in Muscat, and in Buraymi. And we check when it is 100 gram on the panel or 200, you can see that the losses, the power reduction increased. The red one here, it's increased. So more dust coming, more reduction or efficiency reduced more. But in another way, this information have been taken and then compared with other locations outside Oman, in other countries, okay? As example, in Nigeria, in Hong Kong, in China, in Dhaka, in Sohar, this is our study, in Abu Dhabi, Riyadh, and other countries. Each one of these bars represent country, okay? And here I'm talking about daily losses. How much the daily losses because of dust. You can see here the lowest was in Sohar, and frankly speaking, it's in the north part of Oman. For a reason, it's not just like this. It's for a reason, because if you look to this part, okay, let's assume this is roughly, okay. Here is the sea. Here Sohar, we are here Masandam, here Ras Al Had, and so this is the north part of Oman. This area is really suitable area because here we have water, okay? No dust coming from water. Besides cooling of the panel and make the environment more neutral. By the way, I'm giving you the conclusions of some of my studies I already published. And here Al-Hajar series, mountain series, right? Which make a barrier for dust storm to coming from the desert here. So this is one of the best locations in the region to install large power plant. Anyway, another, as I mentioned, was or mismatch because of the wires, as you can see here. You see here, sometimes we put them inside insulator to make sure that it's not affected with time with the environment, okay? And the design of these cables, selecting cables from the market, it needs to be according to formula and equation to make sure that we are selecting the optimum size. But at the end, we have losses. Usually losses, they assume it's around 5%. So if I assume it's 0.95, then I multiply by the previous number, more losses coming. Also the converter, if it is DC-DC converter, if it is inverter, when I convert it from DC to AC, or a smooth from DC, non-smooth or non-regulated into DC regulated, we have losses because this is circuit, it contains elements, we have losses. So here, one of my published article related to this point particularly, you can see that if we take the ideal situation, no losses, then we have this, let me say curve, the blue one, the red when we have losses because of the converter of the inverter, and because of the temperature we have more reduction. This is power with respect to time. So while we have more losses because of converter, because temperature, because that's the curve going down, the productivity going down. These are some articles related to this particular point. Now let me summarize this discussion. I have 100-watt PV module. I manufacture it inside the factory, but what I expect from it, I have losses. I multiply by 0.95, 0.89, 0.93, 0.95, 0.9. So best situation, I may get 67 out of 100. Loss is expected to be high for many reasons. Now this number, you take it, it could be improved, increase or decrease based on these parameters, based on the losses we have, which is different from, as I mentioned, location to location, technology to technology. Another point worth to be mentioned here, I would just mention it, and then we will discuss it when we reach life cycle cost at the end of the semester. When we discuss life cycle cost and cost analysis, we will talk more about them, which is the economic of installation. I mentioned that the PV cost in general going down with time. Okay, no, today we're talking about less than $1 per watt. For each watt, it means 100 watt, $100. Frankly speaking, it is lower than this. It's if you go to Dubai now, 100 watt, it may cost you $25. Okay, some low quality, definitely PVs. Anyway, to install it, many things need to be considered and many parameters affect. As example, we will account the capital cost, the cost at the beginning, how much it cost me, the support and accessories, circuit breaker, structure, and so. Inverter, installation and commissioning, all these need to be accounted. Okay, we will talk about them, as I mentioned, in life cycle costs, and we will calculate them. And but at the end, from all this story of calculation, these costs and estimate them, we want to know the cost, COE, the cost of energy, how much it cost me. As example, if the cost, it cost me for each kilowatt hour, it cost me 10 paise, okay? Comparing with the electricity coming from the grid, which may cost me 25 paise. Definitely I go for solar because it's cheaper. So from this calculation, I want to know, is it cheap or is it costly? If it is cheap, I will go for this option. Many elements could help, As example, if we have feed-in tariff, or let me say incentive support for renewable energy in the country, then this will help. Okay, I've been talking about this since 2003, 2004 in media and even in Oman TV, and I'm encouraged to have, let me say, regulation and policy. 2018 it came in March. We have policy and regulation to install solar panels on the roof of PV. I talk about this also in my channel if you follow it. Okay, I have some series and try to upload them to my channel. You can have an idea about the situation since that time until today. One of the things also is the payback period, because this is related to how long it take to return back my investment. I pay, as example, 1,000 Omani Riyal to install system. How long it took from me to return back my investment? Is it 5 years, 10 years, 15 years? Because based on this, I will say that this is a good investment or not good. Okay. We will discuss this, as I mentioned, just here I would like to mention it. Some parameters also indirect may affect the cost. As example, the site preparation. Some sites are already there. It's prepared. As example, roof of your house. But some location you want to install your panels, maybe there are some trees need to be removed, some places need to be cleaned and arranged, and so. So this is may add extra cost. The design itself, it's another cost to be added. Installation labor, as example, workers. If you go to China, the workers there, I mean, you pay less. If you do the same system in Europe or in US, the labor there is high cost. Okay. The location, if you can access to the location to do maintenance or difficult to access to the location, and so on. All these need to be considered. Another point is the rural electrification. In some villages and some locations far away from civilization, as example, if we talk in Oman, let's talk about Masira Island. Okay, if you go there, it's far away from the grid. There is water, there is the sea there, and it's difficult to connect using underwater cable. And they use usually now diesel, as example, for power plant. I visit there and I have project 12 mega there. We work with the research council, maybe 6 years back with them, and it's costly. The electricity there is costly because the way and because the location itself, its needs. Looking for solar or wind will be one of the best options, and there is a plan to do this. In some locations, as example, you see here, this is in Sharqiya, okay? Some people, they use panel here to provide their needs, and their needs are not that much. They talk about charging their laptops or mobile phone, watching TVs, which is less consumption. So this is one of the best application. Some of our students participated in some projects related to United Nations or related to IEEE, and they visit some villages in different places in Indonesia, in Malaysia, in Thailand, and they try to help the villagers, okay, there to provide their electricity needs, because they cannot use diesel engine or there is no grid connected to connect to it. One more issue is the using solar photovoltaic and solar energy in the space. Okay, we saw this in animation and in cartoon. You remember Adlan and Nina, I mentioned for it when I start talking about solar photovoltaic. Okay, talk about the future, war would happen, nuclear war, and then energy sources will go on. Most of movies, Hollywood movies, talking about this, they go to the same point at the end. Solar photovoltaic. And what happened, we saw this in the movies. We thought that it is only scientific imagination. Yes, it's scientific imagination, but it's coming from theorems. It's not just for entertainment. No, it's coming from theorems. There is theorem talking about having a satellite or a station in the space collecting the 1,360 watt per square meter coming from the sun and concentrated in a beam, similar to Adnan Media exactly, and set it to a collector on the Earth. So this theorem is talking about what we call it space-based solar power, SBSP. SP. Okay, they make a satellite or a station there, and they collect the energy and send it as a laser beam as a beam to the station, and they make a estimation here for the power to be collected or energy to be collected, which is the power in the space, power on the earth. It will be power on the space by square of RIV over R. These represent the mean and actual distance from the center and receiver, from the satellite and the plant on the. By the way, I'll just give a brief, otherwise there is many formula and a lot of to be say here, but just to give you an idea, there are many plans for using photovoltaic in not only on we know that in the space it is the best option, but not only in cities and on the lands and the water and in many other locations and applications. I will stop here. There is a lot to be said here actually on the applications, and I enjoy when I talk about solar photovoltaic applications, but due to limited time, I will leave the remaining time if you have any question.